We need system of resistors to control current in practical applications. There are two ways resistors are arranged, one in series and one in parallel. Electric circuit in which three resistors having resistances R1, R2 and R3 respectively are joined end to end. They are said to be connected in series. Combination of resistors in which three resistors are connected together between points A and B, then the resistors are said to be connected in parallel. What happens to the value of current when a number of resistors are connected in series in a circuit? Let us understand this with an activity. Join three resistors of different values in series and connect them with a battery, an ammeter and a plug key as shown. Let the resistors be of values like 1 ohm, 2 ohm, 3 ohm, etc. and a battery of 6 volts for performing this activity. Plug the key. Note the ammeter reading. Change the position of ammeter to anywhere in between the resistors. Note the ammeter reading each time. Do you find any change in the value of the current through the ammeter? You will observe that the value of the current in the ammeter is the same, independent of its position in the electric circuit. It means that in a series combination of resistors, the current is the same in every part of the circuit or the same current through each resistor. Let us perform another activity. Insert a voltmeter across the ends X and Y of the series combination of three resistors as shown. Plug the key in the circuit and note the voltmeter reading. It gives the potential difference across the series combination of resistors. Let it be V. Now measure the potential difference across the two terminals of the battery. Compare the two values. Take out the plug key and disconnect the voltmeter. Now insert the voltmeter across the ends X and P of the first resistor as shown. Plug the key and measure the potential difference across the first resistor. Let it be V1. Similarly, measure the potential difference across the other two resistors separately. Let these values be V2 and V3 respectively. Let us now deduce a relationship between V, V1, V2 and V3. Observe that the potential difference V is equal to the sum of potential differences V1, V2 and V3. That is, the potential difference across a combination of resistors in series is equal to the sum of potential difference across the individual resistors. That is, V is equal to V1 plus V2 plus V3. We can derive using V is equal to IR and find that Rs is equal to R1 plus R2 plus R3. We can conclude that when several resistors are joined in series, the resistance of the combination Rs equals the sum of their individual resistances R1, R2, R3 and is thus greater than any individual resistance.